Alright, today guys we're learning the Moivre's theorem. The way in which we're going to do this is we're going to use this question over here as a showcase. We're not going to understand where de Moivre's theorem comes from, we're just going to learn its application today, like simple application, and then in the next lesson we're going to have a look at why it sort of is. Not necessarily, we're not going to go too deep, but we're just going to look at further applications basically, which will build understanding. So today's learning is simplify 2 root 3 plus 2i all to the power of 6, and we want to represent this in Cartesian form, also what I've been calling rectangular form. We're going to do this in 3 stages. First stage is we're going to convert inside here into polar form, after which we're going to simplify it to the power of 6 using de Moivre's theorem. Then after that, we're going to convert it back into rectangular, or also known as Cartesian form. So first thing we're going to start off with is we're going to ignore the brackets and to the power of 6, and we're just going to convert 2 root 3 plus 2i into polar form. To do this, I'm going to start off by going modulus of 2 root 3 plus 2i. Modulus of this is just get the real and the imaginary components and from through Pythagoras' theorem to get the length. So this is going to be 2 root 3 squared plus 2 all squared is going to be root 16, which is just 4. Alright, we've got the modulus here. Next, we're going to find the argument. Again, take note of the notation. I haven't named inside the brackets here, I'm just using it like that. So this is going to be arg of 2 root 3 plus 2i. Again, think about what quadrant we're in. We're in first quadrant, so we're out here, which means our theta is just our phi. Next, we're going to go inverse tan of 2 over 2 root 3. This is going to give us 1 over root 3. Now, to this point, we could go for our calculators, or we can think, do we know what the known value of inverse tan of 1 over root 3 is? Remember with sine, you're going to go, what is it? You've got sine, you've got cosine. This is going to be 0, 30, 45, 60, 90. First one's always going to be for sine. Sine starts at 0, then it goes up to a half, then it goes up to, what is it? Sorry, root 2 on 2, root 3 on 2, root 4 on 2, also known as 1. Does that ring a bell? And cosine does the opposite. 1 root 3 on 2, root 2 on 2, root 1 on 2, also just a half, and then down to 0. So tangent is going to be, first one's going to be 0 on 1, which is just 0. This is going to be a half over root 3 on 2. This is going to be 1, and so on. Yep. Do we remember? Yeah. So this guy over here is 1 over root 3, which means that this guy is pi on 6. Yeah. We need to remember that because it's going to be quite beneficial for this part of the topic. So pi on 6 radians.
I got the sine cos one there.
If you got the sine and cosine one down, then you know the tangent one. It's alright, I forgot about them earlier as well, but I know they exist. Okay, so the argument's pi on 6. Therefore, we can rewrite this guy over here as 2 root 3 plus 2i all to the power of 6 is going to be the same as This is going to be, I'll use square brackets now. Where are we? 4 cis pi on 6 all to the power of 6. And it's at this point where we're sort of stuck. We have to use this new theorem called de Moivre's theorem, or de Moivre's if you want to give it an Australian accent. The theorem itself is Z cis, and we'll say just theta, all to the power of n is the same as saying z modulus of z to the power of n times cis n theta. Is that cool?
Yep.
Where n is a rational number. Where's my red pen? So this over here, this is de Moivre's theorem. This is the tool we use to simplify things raised to a higher power.
What's the cube?
The cube, where?
Cube. Cube. Of the letter.
Oh, the Q means rational number. Yeah. So R is for real, Q is for rational, Z is for integer, N is for natural number, C is for complex. Okay, so using this theorem over here, we can actually change this. So this is going to turn 4 cis pi on 6 to the power of 6 into 4 to the power of 6. Cis 6 times pi on 6. Simplifying this out, 4 to the power of 6 is, I believe it's 4096. Cis, and then this will be 6 pi on 6 is just pi. Expanding this out, 4096 sine pi plus I sine pi. Sine to the pi is,
Close.
sine to the pi is, oh sorry, my bad. Cos to the pi is,
-1.
yep, so it's negative 4096 plus
0.
So there's your result. So it looks like a question that's quite trifling, but in actuality, using de Moivre's theorem, it makes the question very straightforward. This appeared in the external, I think 2 years ago. It was, the questions themselves look quite challenging, but if you remember de Moivre's theorem, it's not hard at all. But this is for now, this is our entry level. Remember, we don't have to understand why this is, we just have to know to do the transformation. Next lesson, we use this transformation to find multiple roots of a number. Sound all right?
Yep.
Cool.